We are live.
We are live, yes. Hi everyone. Bonsoir les jeunes voix. Good evening everyone. I hope you can hear me well, and I'm very happy to introduce this third event for the Geneva Serverless Meetup. If you can hear me correctly, just put a thumbs up in the chat, and I'll continue. Okay.
Yeah, we have some delays, so I'm pretty sure we can continue.
Okay, perfect. So just before I introduce my guest, I'd like to thank you a few people who filled the survey last month, but I'm not sure I can take any decision based on 5 answers. So please, it only takes 1 minute to answer. If you can scan this QR code and take 1 minute to fill the survey, it will help for me to work with this meetup. Thank you. And now I have the great pleasure to welcome Slobodan. So a few months ago, Slobodan wrote a great article about testing and hexagonal architecture, and it resonated in me. So lambda function is a piece of code and thus deserves to be tested. And hexagonal architecture is a great approach to perform unit tests, and so Slobodan will explain why and how you should use it. And just a small word on another great article he wrote last week about GraphQL and AppSync. It's really pleasant to read and very insightful. So just look for Slobodan on Twitter and you will find the article. Now, warm welcome to Slobodan. Slobodan, the floor is yours, please.
Thank you. So let me share my screen and we can start. Well, just a second. Okay, so we should be set. Okay, so today we'll talk about testing, but before we start talking about testing, what do you think is the scariest thing about serverless? I talk to many people and people using serverless, and I'm always trying to find what's really the scariest thing for everyone. So some people are mentioning long-running tasks. That was a big problem in the beginning, but now it's not that. It's not a problem anymore, basically, because you can run your Lambda functions for 15 minutes or longer, not longer, but for 15 minutes. And then if you need longer, you can use like different things. For example, on AWS, you could use Fargate. On Microsoft, you have durable functions and many other things. So long-running tasks are not a big problem anymore. What about compliance? If you're building some application that needs some certain compliance, that was a big problem with serverless at the beginning. It's still a problem if you need something really special to some countries that are not like fully supported, but most of the major serverless providers, and I mostly talk about AWS because that's the one that I use most of the time, actually all the time. You have all the compliance that you need for serverless services in AWS. So your Lambda and API gateway, almost any other service is PCI compliant, HIPAA compliant, and everything else. So that's not a big problem anymore. At the beginning, using big binaries and large dependencies in general was a huge problem, but that's becoming less and less a problem because now we have layers, and there are some other ways that you can do that you can basically reuse some binaries in multiple serverless functions and things like this. So that's not a huge problem anymore. Well, cold start, that was a huge problem in the beginning. To explain cold start a bit better, when you're starting your server, it takes like some time to start, and then it's running in the background. But with a Lambda function, you basically, AWS will start that serverless function when you have some request for that function. So that's that first few, let's say hundreds of milliseconds now, or even less than that, is cold start. When they started the first time, they will keep it warm for some time. But now, if you're using Node.js, or if you're not building if you're not putting too much dependencies into one Lambda function, that's not a big problem anymore. For our application, I think our common cold starts are less than 100 milliseconds now for Node.js. So it's almost like not important at all. But what about cold starts with virtual private cloud? That was a big issue. So even 2-3 years ago, when you tried to put your Lambda function in VPC, it took like 10 to 15 seconds to start that function for the first time. So that was huge, and that was a blocker for many people. Now we have like that decreased a lot. It's less than 1 minute now. Sorry, yeah, it's less than 1 second now. But even if that's a big delay for you, you can use something called reserve capacity, and then reserve at least one Lambda function or multiple Lambda functions in the background that will always start immediately when you have a new request. So that's not a huge issue anymore. What about logging and development, local development and debugging? That's still a big pain for people starting with serverless. So it's really hard. Instead of having one big application that you can run on your local machine, you have like a lot of small functions, and you can easily simulate Lambda function. But what about Cognito or some other services like Kinesis and things like this? It's really hard to locally develop these kind of applications, and it's not easy to debug them. Luckily, there are some tools that can help us. For example, for local development, SAM can run a local version of the application, at least Lambda functions, API gateway, and some other things. Amplify can simulate AppSync and many other things locally. And for debugging, tools are improving every day, and you can use some of the third-party services. So that's a big problem, but not a blocker anymore. That's something that we are getting used to. And one of the big things that people are afraid of is losing control. So you don't control your infrastructure anymore, which sounds like a big problem, but it's actually a benefit, especially if you're running a startup or something like that. If I don't need to think about like maintaining my infrastructure and everything, I still need to think about if everything works in the background. Maybe I made some mistake and or used some service in a way that I shouldn't use it. But basically, I'm not losing my control. I basically delegating some of that control to someone that does that much better than I do, for example, to AWS. So for me, this is not a huge issue, but for some people it is. But whenever you talk about, also, sorry, I forgot one of my favorite things. So Node.js, people don't like Node.js. Not everyone, but a lot of people, especially in AWS, don't like Node.js that much. So that's a problem for some people, but you can use Python and many other things. And I'm just kidding. This is really not a problem. So there's one thing that whenever you're mentioning serverless to someone that is not using serverless, there's a thing that everyone will mention. It doesn't matter if that person is a developer or some business person, or maybe that person is doing something else, but everyone will mention big, bad vendor lock-in. That sounds really, really scary. But what's vendor lock-in at all? Let's try to understand what vendor lock-in is, and then after that, maybe it will sound less scary or more scary, we'll see. So if I go to Wikipedia, I'll see that in economics, vendor lock-in makes a customer dependent on a vendor for products and services, unable to use another vendor without substantial switching costs. Well, okay, sounds reasonable, but I don't like these definitions. So let's try to explain a bit simpler so we can understand what really vendor lock-in is. And let's use cloud computing as an example, because we're talking about cloud vendor lock-in now. So let's say that you need a server for something. I don't know why, but you just need a server to do something. So you have multiple options. You can buy a server or rent a server. And most of the time you don't want to buy that server because no one is doing that anymore. You need to maintain the physical infrastructure also. If you buy your server, but basically you need to care about your internet connection to be sure that everything works. So you don't do that. You want to rent it. Fortunately, there are people that has a lot of servers, and you can rent a server from them. For example, Jeff, he has a lot of servers in his basement, and Jeff decided that he don't need all of these servers, so he can rent one to you. So you rent this one server from Jeff, and for you, this is a cloud. So you start using your application, and many other people start renting servers from Jeff. And after some time, Jeff is really smart, and he knows how people are using these servers. For example, he knows that you have a database on his server and a few other things. So instead of just giving you a server, Jeff created a few, let's say, services. So you can use a database without renting a server. You can just like use a database as a product or a service. You can do the same with some cache, with let's say computing, machine learning, and many other things. And even better, you can pay only for what you're using at the moment. So if you don't need a database, you will not pay for that. If you need a database, you'll pay just for requests that you're sending and things like this. So that sounds really good. And you're really happy with this, and you're falling in love with this cloud. And you build your application that works perfectly now on Jeff's cloud. And the problem is, what if Jeff is actually a villain? And at some point, he wants you to start using his servers, and then he wants to increase the cost of all the services that he's offering. Well, at that moment, your wallet will not be happy for sure, and your application will not be profitable anymore, and you're basically locked in. But what does that mean? You can always go to and find some other guy with a lot of servers. Let's call this one Bill. And Bill also has something similar. He has his own database, his own like computing platform, and many other things. So you can try to migrate your application to Bill's cloud. But the problem is that Jeff's database is not the same as Bill's database, and it's the same for all of these other services. And the migration itself will cost you even more than continuing using Jeff's cloud. So basically, that's vendor lock-in in the cloud. And I completely agree with Mark Schwartz. He's an enterprise strategist at AWS. He said that the term lock-in is misleading because you're not really locked in. What we are really talking about is switching costs. And what does that mean is whenever you commit yourself to any platform or vendor, you have some switching cost assigned to that if you later want to change that to something else. And it's not just in cloud. For example, if you choose to write your application in PHP, PHP itself is free. But if you decide at some point to migrate to Node.js or Go or something else, maybe because you need something specific that other languages has, you have a significant switching cost assigned to that migration because it's not just moving that to some other place. So how do we fight that vendor lock-in thing? Well, let's not talk about vendor lock-in. How do we fight that switching costs, and how we actually not fight? How do we keep our switching costs reasonable? Well, there are a few things you can do. First, you need to plan and analyze before you build something. And the questions you should ask yourself is, how likely will I need to switch, and what would be the cost of that switch? There are some things that are not likely that you'll need to change in some not that distant future. For example, if you're using S3, S3 is really available and relatively cheap if you're not doing something, if you don't have like a really huge amount of data and things like these. So there's not a big possibility that you'll need to switch to something else in the next few months or years or something like that. So even if you don't need to care about that switching cost that much, because even if you need to switch at some point in the distant future, that's fine. It will it will be okay because your application will be able to use that service for a long time, and you'll make some profit. So it's okay to invest some time and money to switch to something else in the distant future. But for example, if you're using some analytics tool and you're not sure, you're just like investigating which one will work the best for you, maybe you want to keep switching cost for that a bit lower, because you will probably try a few other tools before you find the one that works for you. Then you need a good architecture that will allow you to maintain that switching cost reasonable. And finally, you need some deployment procedures, because if you deploy everything manually, every switch will be really, really hard. So that leads us to our topic for today, and we'll talk about writing testable serverless applications and preventing vendor lock-in with something called hexagonal architecture. And before we continue, let me introduce myself. I'm Slobodan Stojanovic. I'm CTO and partner in Cloud Horizon and Vacation Tracker. Vacation Tracker is our product. It's basically a leave tracking management system that is fully built on serverless, and we are using now AppSync. So the article that was mentioned in the introduction was basically about some things that we are using now on Vacation Tracker. Besides that, with my friend Alexander Simovic, I wrote serverless applications with Node.js book published by Manning Publication, and I'm also AWS Serverless Hero. I write a lot about serverless, so you can follow all the articles and soon other types of content on my website, which is slobodan.me. But I'm not the topic of today's presentation, so let's go back to writing testable serverless apps using hexagonal architecture. Before we dive deep into serverless apps, let's see what makes some application testable and why testing is important at all. So basically, I'm pretty sure that most of the people know why testing is important for most of the applications, but let's focus on serverless apps here. So with serverless, we delegate some things to cloud providers such as AWS, and that's infrastructure part. So you don't really need to test some of these things, because I'm pretty sure that AWS is doing excellent job with testing their services. But most of the time, our applications, serverless applications, are not fully isolated monoliths without any integrations. Instead, our apps are integrated with many external services or some other functionalities from the same cloud provider, sometimes with some other cloud providers and things like these. And there are a lot of connections there. And let's take an example of Vacation Tracker. Basically, we have a chat bot for Slack and now for Microsoft Teams, and you can basically from Slack request a leave. You can type in the days and everything you want, and then when you send a request, that message will be sent to our online dashboard, but also to Slack message to your approver and manager, and then they will be able to approve your vacation. But when you do this, a lot of things are happening in the background. So first, Slack will just send, whenever you type /vacation, Slack will send that to our Amazon API gateway, our API on Amazon API gateway. API gateway will decide which type of, actually which endpoint are we invoking. So it will trigger different Lambda functions in the background. So for example, if you're using /command, it will trigger one Lambda function. And if you're clicking on a button, it will trigger completely another function. And that will be because we need to answer in 3 seconds, and 3 seconds is a lot of time, but sometimes we want to do some complex calculations and things like these. We don't want to do that immediately in this Lambda function. Instead, we send our message to Amazon Event Bridge, and then we just return the reply to Slack and tell Slack that we received the message. In the background, Event Bridge will trigger some other functions that will do our business logic and send a message back to our requester. So as you can see, there are a lot of integrations here, but many of these integrations can change or fail every moment. So basically, Slack can stop sending us messages for some reason. Maybe Slack is down, which is probably not the huge problem, because if your Slack is down, probably your biggest problem is not that vacation tracker is not working at that moment, but at some point it's possible that Slack changed their payload or something like that. It happened multiple times, so this part can change. Also, API gateway maybe don't have a permission to trigger our Lambda function. Or for example, maybe we are sending a bad payload to Amazon Event Bridge, or maybe we are sending a too big payload or something like that. So this can fail. And finally, even this can fail. For example, if our Lambda function is not subscribed to correct event bridge rule. So a lot of things can fail. And tests don't prevent these changes. They make sure that changes that you are doing are not accidental. So whenever you do something, you can easily check with your tests if you break some of the expected behavior that you have in your app at that point. It's even more important when your app is like a lot of small Lambda functions and things like this, because maybe you have a large team. So maybe someone else changed something and they don't know that you did something else before that. So tests are really important. So how do we prevent these changes? So how can we prevent these changes? As we said, tests will not prevent them. Tests will help us to know that things we change are not changed accidentally. So we can't. Our application needs to adapt fast to new, let's say, new reality or whatever. Basically, we'll discuss that part later and see how we can make our applications adapt fast. But if we go back to testing, okay, we know why do we need test serverless applications, but what should we test in serverless application? In traditional applications, there's something called testing pyramid. It's explained and defined by Mike Cohn in his book Succeeding with Agile. I think it was like 10 years ago or something like that. And it looks something similar to this. I just added one thing. So testing out, actually he calls this automated testing pyramid. And basically he says that unit tests are really fast and cheap because you test that part of code in isolation from everything else. So you should have a lot of unit tests. Your integration tests or service tests are more expensive and slower because, for example, you need to integrate to a database or something like that. So you need to have less integration tests. And finally, end-to-end or UI tests are most expensive and slowest because you need to have copy of your application, and you also need to simulate clicks. So that's slow and expensive. So you don't need that many UI and automated tests, but you still need some of them. And finally, a lot of applications, this is the part that I'm adding to this pyramid, a lot of applications require manual session-based testing because you basically, there are some things that are not easy to automate, and it's useful to have a human that will test some parts of the application. These tests are the slowest and the most expensive ones because basically people still need to do them, and you need to have a copy of the application for your team to do these tests. Let's see serverless testing pyramid. I would say that this testing pyramid is still a pyramid, but not Egyptian pyramid. Maybe it's Mayan pyramid or something like that. So unit tests are still fast and cheap because they're still the same, basically. For integration tests, they're faster and cheaper than before because serverless is faster and cheaper. For example, let's say that I want to test the DynamoDB database. I can easily spin up one table and run tests against that table and then destroy that table. It will cost me like less than a few cents, and everything will be done in a few seconds. So that's why they're faster and cheaper than before. And again, UI tests or end-to-end tests are still slower and more expensive, but they're a bit faster and cheaper than before because you can easily spin up a copy of your application. If you're fully serverless, that will not cost you anything if no one is using that other copy of your application. And you can do things in parallel because serverless is great for parallelization. And manual session-based testing stays the same. There are some things you can do for them, but let's focus on automated tests today. So integration tests, as I said, are cheaper, but also they are more important than ever before because common serverless application is split into many small details, and you want to be sure that your integrations are working correctly. So, okay, that's testable part, but let's mention this architecture part before we dive deep into some examples and see how we can use hexagonal architecture. Why is the hexagonal architecture important in general? Well, because architecture allows you to do some things faster than so good architecture will allow you to switch faster to something else or adapt your application faster or test your application easier and things like this. And which architecture is the best for a serverless application? Well, there's no one specific architecture that you should use, but any architecture that will help you to build your application, of course, and then to maintain and develop your application and test your application easily and keep your switching costs low will be perfect for serverless. Because sooner or later, you'll need to switch or migrate some parts of your application. And most of the time, that will not be to another cloud vendor. It doesn't matter which one do you use. Most of the time, you'll need to switch to some new service, new integration, and maybe you just upgrade one part of the application, but you're, for example, as you saw, we are using these Lambda functions and Event Bridge for our Slack integration, but the rest of our application changed in the past few months. And now instead of API and Lambdas, we are using AppSync. So we basically needed to migrate even our Slack integration to that new architecture. So things are changing because applications are evolving over time. So there are certain risks that you should consider when building application, and there are 4 risks that my friend Alexander defined in our book, and I really like his definition. So let's do them. First, there are configuration risks. You need to be sure that you configured your application correctly. So for example, if your Lambda function talks to a right event bridge or right DynamoDB table and things like this, then there are technical workflow risks. For example, if you're handling your errors and success responses correctly and things like this. Then, of course, there are business logic risks. If that talks about the way your application works and for example, if your app is really doing what it should do and things like this. And finally, there are some integration risks. If everything works correctly with other things, for example, if you're having correct permission rights to write to that DynamoDB table or event bridge, or if event bridge event can trigger that specific function and things like this. So one of the architectures that I really like and that fits perfectly, that helps you to manage all these risks that we mentioned is hexagonal architecture or ports and adapters. And that leads us to this part of the presentation. So its creator, Alistair Coburn, explains hexagonal architecture as an architecture that allows an application to equally be driven by users, programs, automated tests, or batch scripts, and to be developed and tested in isolation from its eventual runtime devices and databases. And this sounds like perfect fit for serverless because, as we mentioned, it's not always easy to develop and test your application locally. If you can develop it in isolations from its eventual runtime, that sounds like something that can help you a lot. It's also called ports and adapters because it works like ports and adapters. For example, let's say that in some happy times, I traveled from Belgrade, where I'm right now, to Switzerland, to Zurich, to some conference. My plug for my laptop was not working in my hotel room because the power socket was different. So instead of buying like the whole new cable, I was able just to buy a small adapter, and my I was able to charge my laptop. But often in our application, we are not doing the same. Instead of like changing a small layer of our code, we often need to rewrite everything if we want to connect to another service. So with hexagonal architecture, our code should look something like this. We have business logic, which is fully isolated from connections from these, let's say, integrations. And this business logic has certain ports. And these ports are, for example, port for incoming event, port for notification, and port for database. Let's say that we want to receive some kind of trigger, save some data to a database, and send some notification when everything is done. So if you're running that on a cloud, you probably want to trigger your business logic by Lambda event adapter, actually by a Lambda event. So you use a Lambda event adapter, and maybe to save the data to DynamoDB or MongoDB. So you need DynamoDB adapter and MongoDB adapter and things like these. And then notification can go through SNS or something like that. So you need adapter for that. But locally, when you're testing and developing your application, maybe you can use some local trigger, and then maybe you can have in-memory adapter for to store the data to some in-memory database so you can test everything. And finally, you can send some local notifications instead of sending everything to SNS, so you can develop your application even if you're like somewhere without internet connection. Or I know that's not happening often now, but basically it can speed you up a lot when you're developing your application. So if you go back to vacation tracker, you remember this example. Let's try to analyze this one function. Inside this function, we have something like this. First, our functions, we use TypeScript. So for us, it's not lambda.js, but lambda.ts. But all of our functions follow the same structure. Every function has some kind of a lambda.ts file, which basically wires the dependencies. It's really simple file, and it doesn't have any tests. And then we have business logic. And our business logic receives some event and other things, and it has its own unit tests and integration tests. But as many functions are connected to the same integrations, for example, many functions will send some data to event bridge. Instead of testing each single function against the real event bridge, which will take some time and cost more, we have some kind of local notification repository that allows us to send notifications and make sure that that the port for our business logic for notifications work correctly with some adapter that has the same interface. And then we have a real event bridge repository that has the same adapter as this local notification repository. And it has its own unit tests and its own integration tests. And integration tests for our event bridge repository are against the real Amazon event bridge. So we always know that this part of code works with the real AWS infrastructure or any other external service that we want to integrate to. And we also have, for example, event parser function that can parse the event that is that we are sending to our business logic. And because this is not integrating to anything else, it has only unit tests. So let's see some code for this. I'll walk you through this. It's a really simple example, but there are a lot of things on the screen. So first, we have some dependencies. We have some HTTP response, which allows us to just generate the response to API gateway. We have that parse API event, a function. This is the function that you see, that's event parser basically. And we also have that event bridge repository. So you're now seeing our lambda.js file. Our lambda.js file exports some handler function that receives the event from, for example, let's say AWS Lambda. It creates an instance of event bridge repository, it passes the topic via environment variable and whatever. Now we have the instance of that repository, and then we are invoking our business logic with event, that function that will allow our business logic to parse the event, and finally notification repository. And then when we get the response, we'll simply return the empty response to Slack. Basically, this is the only line that matters in this code. We are basically invoking our business logic with different things. And when we do unit tests, we pass some static values as an event. We pass a parser mock, and we pass mock notification repository instance. And we test everything with mocks, so it's really easy to test that. But for integration tests, we can do something similar. We have some static values for event. We have real parser function because it doesn't have any external dependencies. And we have some local notification adapter that has the same the same interface as our real adapter. And then our real adapter has its own integration test. So we are sure that they have the same interface, but it's much easier to test this function in isolation than everything else. So it's simple and nice. And then what about end-to-end and unit tests? Basically, serverless is mainly a backend thing, but it can help you with UI tests because UI tests are slow and expensive, as we mentioned, and big benefits of serverless are that serverless is cheap and it has easy, fast parallelization. So what you can do, you can basically spin the instance of a browser in many Lambda functions and simply test your application easily in parallel. And of course, you can set up another instance of your application easily, so you can run your tests against that instance of your application, and you'll pay for that instance only if you're using it. Of course, you can use some your favorite tool for end-to-end tests, such as Cypress or maybe some other tools, and Selenium and things like this. And you can spin up another instance of your application, test against that instance, and maybe destroy it after that. But do you remember big bad vendor lock-in that we mentioned at the beginning? It's still scary, right? So let's see how does hexagonal architecture help you with fighting that vendor lock-in or switching costs. Well, let me tell you another story. So you remember Vacation Tracker. We started with actually in-company hackathon a long time ago when we worked in an office. Now everyone is remotely, of course. Then we built like serverless prototype and people started using our product. So we assembled a small team actually that was just one full-time developer. He was mostly front-end developer at that moment. And initial product was serverless chatbot for Slack and a small Express.js and MongoDB application. Why? Because our full-time developer had some experience with Express.js and Mongo, but he has zero experience with serverless. So we started with something familiar to him. So he built like a simple app, and after a few months, we grown fast to 200 plus teams using it. Now we have much more than that. And of course, we had a lot of bad decisions as a bonus while we were building the first version of our application. And we did a lot of migrations in the past few months. So first ones were getting rid of Express API and building serverless API. Then we replaced MongoDB with DynamoDB. And finally, we are now finishing our migration from API Gateway and serverless API to AppSync and GraphQL. Why? Because it helped us to focus on our business logic instead of maintaining a lot of functions and things like this. But that's the topic of some other talk. Now let's talk about DynamoDB to MongoDB switch. So it's a big switch. You're switching the database, and it's never easy. But besides of planning how to transfer the data from MongoDB to DynamoDB, we needed to change our functions to connect to DynamoDB and pull the data from Dynamo. And Dynamo has different rules than MongoDB. But what we did, we basically created an interface for our MongoDB. So you do something like a new MongoDB repository and pass some things, and then you get the instance of that repository. For example, let's store that into DB variable or constant. And then if you want to get the user, you do db.getUser by ID, pass the ID, and you get the user. And then we created this, the repository for our DynamoDB table with the same interface. So the same interface means that we can do something like this. We can create a MongoDB instance and DynamoDB instance and run the same function like db.getUser by ID, and then we'll receive a user. The user that we receive from MongoDB should be equal to the user that we are receiving from DynamoDB. And we have a small adapter that will change that data query by specific things that DynamoDB has, like composite keys and things like this. So our application was something like this. Actually, our functions were something like this. We had lambda TS file and main TS file, and they were connected to MongoDB repository. We had unit tests and integration tests with in-memory DB for our main.js or main TS. And then we had integration and unit tests with Mongo repository. We created our DynamoDB repository with the same interface. And then we basically just switched that DB that we are passing to our business logic in lambda.js file. Our main.js file or TS file stayed the same, and it's working without the problems. Unit and integration tests for that files are the same, no changes, everything still works. The only thing that changed is that we basically switched from Mongo repository to DynamoDB repository, and we replaced each of our lambda TS files. And how do we test? How do we write integration tests for DynamoDB? Well, as I said, you can set up and destroy the database. So in your integration tests, for unit tests, it's simple. You can run your unit tests the same way that you do any other unit tests. But for integration tests, basically we can create a new table in before all and destroy it in after all. So if we want to create a table, we can do something like this. We use AWS SDK for Node.js, and we can just prepare some params. We have one main database for on DynamoDB, main table that stores all the events, and then we have some read tables. So we have, it's not really single table design, it's single table for events, and then there are a few other tables that are storing specific data that is not retrieved at the same time at any point. So we put some params, like which table to create and what are the keys and things like these. We created a table by using DynamoDB create table, and we are using promises. And when that finishes, our database table is not ready. So we need for table exist event before we can continue. Then when we have that, we can start with our tests, test everything we want. Maybe in this before all, we also want to see the table with some data or something like that. And finally, when everything is done, we can just simply do DynamoDB delete table, put the table name, wait for table not exists event, and yeah, that's it. We have the test. And of course, if you want, it takes like maybe 20 seconds to spin up a new table. So sometimes you want to cache these tables and maybe reuse them in multiple places or something like that. You can do that if you want. You don't need to destroy it at the end and things like this. Maybe you just want to clean it up. Well, we lived happily for some time, but as you can imagine, there are things beyond testing. There are things that you are not able to test. For example, it happened many times that Slack changed their API without telling us, and our app was in production. And how can we prevent that? Well, basically, we are not able to do that. But what we can do, we can have monitoring and track our errors. And then whenever we see some kind of error that was caused, for example, by Slack or some other integration, we can quickly change our adapter or some part of our code, which is not core of our business logic, because the business logic of vacation tracker, a leave tracking tool, is not connection to Slack or any other tool. It's doing something related to leaves. So we can change that layer of the code and fix the problem, redeploy everything. And there are many monitoring error tracking tools that you can use. For example, if you're using AWS, you can use built-in tools such as CloudWatch, X-Ray, and now there are CloudWatch Insights, which are really, really cool. We are using them all the time. But if you want external service, there are many great services such as Hexagonal, Tundra, New Relic, which bought IOPipe, Lumigo, and many others. They will help you to even visualize your application and the data flow through your application and things like these. And often serverless apps are heavily relies on front end or native apps. So make sure that you're tracking errors from your front end or native applications too, because that can help you a lot to make your applications always available and without errors. And one of the big problems that people have with serverless is that instead of one big monolith, we are going to smaller and smaller functions. And when you go to smaller functions, you want to make sure that you have fine-grained permissions and that you don't give too many permissions to a single Lambda function. Because if someone manages to do something with your one Lambda function, they should be limited to, for example, our functions can just read from database or write a specific part of DynamoDB table and things like these. So even if someone can someone manages to get some permissions in your Lambda function, they will not be able to do anything except the specific thing that that function should do. So fine-grained permissions are really, really important. And there are tools that can help you with that. I know for Protego, PureSec, and a few others, but some of them were acquired, so I'm not sure what are the names of these tools anymore. But there are a lot of tools that can help you with that. If you're using like AWS SAM or something like that, SAM will just help you to do that by giving you some template policies that you can just use for different services and things like this. And of course, sometimes even monitoring can help you, because sometimes things are not really wrong in a way that you have some errors in your code. Maybe they're wrong in they're not doing things that your users need. So basically what you want to do is to have direct communication with your end users all the time. And we're trying to put even our developers from time to time in direct contact to some of our customers. That's not happening often, of course, because we don't want to to push them that much. But it's important to understand that the tools that you're building are solving some real world problems. So you need to talk to your direct customers to be sure that the things that you're building have something that your users really need. And with that, you're becoming a true serverless hero. Not like me, I don't have a cape, but you would have like a real application that will work perfectly in all conditions. So that's it. Let's go through a quick summary at the end. Basically, good architecture will help you to maintain your switching costs low, or at least reasonable, because for some things they're not able to be low. Hexagonal architecture is nice, fit for serverless applications, because it will allow you to develop your application locally and then deploy it at the end or something like that. And it will allow you to test your application easily. You should definitely test your integrations, and you should test your application in general, but integration tests are more important than ever. And finally, testing is not always enough. You need to monitor your application and track your errors. And it's useful to do that even on the front end. And when you do that, you'll have your serverless application that will be really easily maintainable, and you will be able to evolve your application over time. That's it from me. Thank you very much. If you want to follow things that I'm writing, you can subscribe on my website. We are preparing some free email workshops for like testing for GraphQL and a few other things. So I'll probably tweet more updates about that. And of course, I'll post that to my list. That's it. Thank you very much.
Thank you, Slobodan. Thank you very much. Now we can open the chat for questions. So actually, I had one question. to start with. Maybe other people will continue. So my question was, you spoke about mocking, you spoke about integration test and bootstrapping some table, DynamoDB table. Do you use something like local stack, or do you really provision a DynamoDB table on your AWS account?
So I'm not using local stack. It's useful, but there's a lot of magic behind that. So I'm not always sure that it works completely the same as AWS should work in the end. So I'm not using that. It would probably be helpful to do that for some things, but instead, what we're doing, we're basically for integration tests, we're provisioning DynamoDB tables because we did that for also for Claudia.js framework that we created a few years ago. And it was really, we tested a lot of things against the real AWS infrastructure. And for end-to-end tests, we of course spin up the full application. But when you're developing your application locally, you don't need to do that. Instead, we have like some really simple local databases that are storing things and retrieving things. Most of the time, that's enough to test your unit because the only complex part about that is testing adapters, basically, which we do with a bit better mocks and, of course, with spinning up the real database in the end. Everything else is done by basically in-memory databases. Often these databases are simple arrays or something like that. It doesn't even matter because as long for integration tests of your business logic, you're basically testing your ports, and then integration tests of the adapter will test if that adapter really does what it should do and if it talks to DynamoDB or anything else. So from my business logic, I don't really care if my data is stored to something that looks like DynamoDB. I just want to test if my integration, like if my interface for adapter really works correctly with my business logic.
Okay, makes sense. Thank you. I don't know if you see the question in the chat. We have a question from Arthur.
So, yeah, Arthur asks, should Lambda functions test make real operation DB or everything should be mocked? So it's not really mocked. Lambda functions are not talking to DynamoDB in my integration tests unless you want to unless you're doing like end-to-end tests and things like this. Instead, they're talking to some kind of database, some local database. For example, Georgia just tweeted that, commented that you can spin up DynamoDB locally. That's a good one. For example, you can use local DynamoDB and use that as a local DB, but also you can use like anything. You can, for some simple functions that does not have any specific, that if I want to test if some values are stored to a DynamoDB table, I can just make a local array that will act like a local database. When I store that data, I just want to be sure that it went through my port and was stored to that array. So I don't really care about DynamoDB at that point. If I have something with some more complex queries or something like that, I may use local DynamoDB or something like that. But basically, it's we are keeping that as simple as we can. So our Lambda functions that we are testing are not talking to DynamoDB almost never. I hope that answers the question. And it's confusing. It seems like something that you need to actually do many things to keep this hexagonal architecture. But in practice, it's much easier than it seems. And that's why I think we should create a few free workshops so people can see this in practice, because it sounds that when you're creating some adapter, it needs to be really complex adapter or something like that. But basically, adapter in Node.js is a simple Node.js function that will receive some kind of attributes that are always in the same format and do something and return the data in the same format. So it should be a simple function, nothing more than that. In Node.js, everything is really simple with functions. So yeah, we don't do complex tests. Basically, what I learned is that hexagonal architecture should help you to simplify your tests, not to overcomplicate your application. What I saw in the past few years with Node.js and front end is that people are writing their code the way that they want, and then to be able to test that code, they need to use really complex mocks and things like this. With hexagonal architecture, I don't need to do that. That's the biggest power of this architecture. Instead, you can do small changes on your code, and then you have full power of easily mocking anything you need. Okay, thanks Arthur for an excellent question, and thanks Georgia for local DynamoDB. That's really great comment. And there's one more question from Jerome. Does your integration tests use copy of the latest prod data or synthetic test data, better variability or predictability? So it really depends what do we test. For some things, we need to use copy of the production data. And for most of the things, we basically have some synthetic test data that where we cover most of the cases and things like this. Sometimes there are some cases in production that we didn't predict it, so we basically use some production data to run tests against them. But most often we have some data that we prepared for our tests, and sometimes, rarely, we do TDD. Most of the time, we write some code, then add some tests, and then when there's something more complex, we do TDD and try to cover everything that we can with tests. And of course, if there's something specific on production, definitely we take that data and use that as our tests. I hope that answers the question. So Georgia said that practical workshop would be extremely nice, and there will be few workshops. First one, as I said, will be free, and it will be email based or something like that, because I don't want to create a lot of videos. I want to create basically a few small articles with a lot of examples. And then early in 2021, we are running a testing serverless application workshop on Senso platform. And there will be more info about that on my Twitter and on my list. Thanks, Jerome, for another excellent question. Is there any other question?
Maybe I have one another. So serverless applications are massively event-driven. We have event bridge, SNS, SQS. We also have a step function in the loop. How do you handle tests for this kind of complex application, especially with step function, which is not really easy to test?
Yeah, that's hard to test. Also, we have now VTL templates, which are hard to test too. If you want to be 100% sure that your application works, you need to have some end-to-end tests that will test your flow, because otherwise it will be really hard to be sure that that everything works for your application. For example, that your rules are set, for example, permissions are set that you can really read from, let's say, SNS notification, that you can read these events and that you can store something to DynamoDB. So we have some end-to-end tests that will cover that. For the other things, we are trying to take things in isolation and test them separately, and then integrate them to something and test just integrations. For step functions are definitely hard to test, and we are trying, whenever we have some Lambda functions inside step functions, we are trying to test them in isolation. But basically for them, we have end-to-end tests that will make sure that everything works in the end, because there are some simulations and things like this, but it's not that easy to test that. Even for AppSync, for example, by migration to AppSync, we don't have this REST API anymore. So there are no Lambda functions that are doing like a query from the database and things like this. Instead, we have AppSync that talks to some kind of read-only databases. And what we do in these cases is that we have unit tests for our VTL templates, because we use VTL templates between GraphQL and DynamoDB. those tests will test different scenarios with these VTL templates, and then in the end we have end-to-end tests to be sure that this connection really works as it should. End-to-end tests sometimes are connected to a front end. Sometimes there are simply a lot of API requests that are sent to our test environment, and actually automated test environment used only for automated tests, and then we know that that works. So it's not easy. Besides that, we have monitoring that helps us to get some issues that even when you test, you will not see them easily. But the idea is you're doing something locally. When you do that locally, you basically run unit tests often. Before you push something, you can run integration tests. When you push something, we'll run all the integration tests. And before we deploy something to some pre-prod or prod environment, we'll run both integration and end-to-end tests. So before any part of the code goes to production, it will run all kinds of the tests. And we also have a QA team that is testing our app manually. And we also have a lot of users that are from time to time finding some edge cases and things like these. Fortunately, they're letting us know whenever they find something cool that we didn't cover. I hope that answers your question. We have one more question from Georgia. I was late, so you might have covered it. Do you guys use SAM? So yeah, we are using SAM at the moment and CloudFormation. And we are slowly looking into CDK, and we are planning to transfer most of the things to CDK at some point. CDK is Cloud Development Kit that allows us to write our infrastructure using TypeScript and a few other things. But as our application is written in TypeScript, I think CDK will be a nice addition because it's even easier to test some parts of the system, and it's somehow more natural for us to write TypeScript instead of maintaining CloudFormation. And it's easier to split your application and have, for example, VTL templates outside of your CloudFormation template and things like this. You can have that with CloudFormation, of course, but it's somehow easier to do that with CDK, and we like it. So we're looking into transition to CDK. It will take some time for sure. Probably I'll have some new articles and meetups, meetup talks when we do that migration. So another question, if I want to understand more about hexagonal architecture, what resources do you recommend? Basically, there are a lot of resources, not that much for serverless. For serverless, I have a few articles, but if you follow Alistair Coburn on Twitter, he's a creator of hexagonal architecture. He's basically retweeting all the cool articles related to hexagonal architecture all the time, so you'll be able to learn a lot about it. You should also look at some of his articles and talks about hexagonal architecture. It's built like 15 years ago, so it's not new. And there are some other architectures that are similar, for example, clean architecture or onion architecture that you can apply the same way to serverless applications. And thanks for the link. This is his website. He fortunately put back that article because at some point that article disappeared from his website. And yeah, this is the good starting point. And then after that, there are a lot of other articles on the internet. I know that the Java community is using serverless hexagonal architecture a lot, and I see it more and more in Node.js applications. So there are a lot of articles. I don't have any specific to recommend except this one. Any other questions? Even if you don't have questions now, feel free to ping me on Twitter or LinkedIn, and I'll be happy to answer your questions and show you some examples or whatever you want. Let's wait a bit more and see if there are any other questions. So I have a question for all of you. Are you using serverless in production or just playing with serverless? It's funny because you're not able to answer me like this, but you can type in YouTube chat. I prefer in-person meetups because then I can talk to a local community after a meetup, and most of the time, every time I meet a lot of really smart people doing really great things. So I guess we don't have any more questions, and that's it. Thank you very much for having me, and thanks for excellent questions.
Thank you. Thank you a lot, Slobodan. It was a pleasure to have you tonight, and hope to see you again on stage for other meetups and other great presentations. Thank you very much.
Thank you.
And thank
Thanks.
you everyone for assisting to this meetup. If you want to present something, oh yeah, hold on.
So let's see if Georgia has one more question or not. No, he's just kidding. Playing with serverless in production. I'm doing that all the time, so that's great.
Perfect. Thank you, everyone. Have a nice evening, and see you soon.
Bye.